today. I have a test tomorrow, so just do a quick little stream to, I guess crank up a little bit, change the setup a little bit, let me know if it's any better. Now you have the questions on the left side, so you guys can, it's on my 7 monitor. We'll try this. Yeah, we'll try that. I don't know what's best, but I don't know if you guys can see the questions that well, but we'll give it a shot for today. Alright, so we did all these questions yesterday, so we left off at... Where did we leave off at? 30. We left off at 30A? 30B. Okay. So, I was doing some calculus, just because I was doing calculus. I'm gonna get my good microphone too. If I'm streaming, I feel like that would be better. Alright, 30B, so we're gonna do 30 for the question. 30C. Hello. I hope this microphone's working. Alright, 30C, here we go. Contrapositive. Let x and y be real numbers. If x and y are both positive, then x plus y is not equal to x plus y. So if x plus y is equal to x plus y, then x and y are negative real numbers. Okay, so this is interesting because since are negative real numbers, x so logically, whatever. Let's put log. Equivalence to the original, blah, 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 blah. It is true. Don't know if that's the case, per se. So we're going to pull up the solutions. Extract 2. Can you guys see the solutions as well? Yes, you can. Awesome. Alright. What are we doing? 3... That's true. Wait, no, that's chapter 2? Oh, chapter 3. Let's see. Okay, I did this wrong. What the fuck did he do? Okay, so it proves it a completely different way. Suppose x, y. I guess my way was wrong. So let's read how they did this. Suppose x, y Such that x is equal to y. What the fuck was the original question asking? Okay, why is it solving D? I'm not... Okay, so there is A, B, C, D here, and they only went up to D. So I think they're missing one. So they were proving C, but C here is D. So I think that's like an error in the textbook, where they added something in the new textbook. So we'll just leave that for now. I just assume I was right. So let's do number D. If so, contrapositive of this would be if x over x squared plus 1 is equal to y squared plus 1, then x is equal to y. Okay. Interesting. Okay, so I guess let's just begin by multiplying it. Don't know if this is the right step. Probably not. Can I factor out? Okay, let's square both sides. No, yeah, let's square both sides. So we get x squared and if we expand it now, no idea if this is right. Oh, this is right. Okay, yeah, then you just, these naturally cancel out, and you're left with x squared is equal to y squared. You root them, and then you get x is equal to y. So, I just write a few words. Simple algebra. Nothing too bad there. E. Let x in R if x cubed plus 5x is equal to 40, then x is greater than 3. Okay, so if x is less than or greater than 3, then x cubed plus 5x is not equal to 40. Okay. Let x equal to 3. Because that's, so we're going to x equal to 3 because basically if we show x is equal to 3 is not true, this value is not going to be true. Like, if x equal to 3 is greater than 40, then we already know that, which is not, because this would be 9 plus 15, which is definitely not 40. And x is less than 3. Oh shit, they're allowing negative numbers as well. Interesting. I don't even know if, I think it would have to be positive anyways. So if x3 plus 5x equal to 40, then x is less than 3. This doesn't make sense. Oh, x cubed, never mind. So this is, yeah, so it's what, x equal to 3, then, I thought it was squared. Apologies. What's 27 plus 15? 27, 42? Thus, so since 3 is like the smallest value that x can take on, and that's already greater than the contrapositive, or that's already greater than 40 in this equation, then we already know that the contrapositive is going to be true, right? 31. The following equations have no rational solutions. Okay, So usually for these types of things, um, parity. So we're waiting to if it's odd or even is going to be very basically your main proof tool when dealing with rational solutions or whatever. And then you usually just do a proof by contradiction or something along those lines. Another important another thing I guess you could do is maybe the well ordering principle. Although I don't think in this textbook they do the well ordering principle yet. I think that comes later. But for now, you do. I think parity is the only way that the only tool that you have to solve these kind of solutions. So 31. Again, immediately obvious. You have x squared plus x cubed. Since x must be odd or even, the sum of two even or odd integers I have to put numbers because it's rational solutions. Even or odd numbers is always odd, thus 1 is always even, sorry. Thus 1 is odd and not possible. Okay, so I don't know how they would make it much more difficult than that, but we'll find out, I'm sure. 32. Oh, my bad. 32. This was A. B. X3 plus X plus 1. Okay, so it's equal to 0. Okay, so now we have, so in the case that X is odd, we have odd plus odd is even. Okay, so it's the same shit again. So since X must be odd or even, x3 plus x is always an even number. Thus, odd plus even is equal to odd. 0 is not possible because 0 is an even number. C, x3 plus 7x. Okay, so again, I guess throwing us for a bit of a curveball here because we have 3x3. Okay, so let's analyze this. So this might actually. Okay, so let's think about it. If x is even, if x is an even number, then this is even and this is even. Then we have odd is equal to even. That's not true. Okay, so what if it's odd? If this is odd, this now would not be odd. So whatever, we don't actually have to wait. So if we do like x5 plus 7, both odd numbers, plus an odd. So this becomes even, plus odd must equal to an odd, but it's equal to 0. So it's not equal to even. Okay, so that's the case if they're both odd. And then again, in the case that they're even is an even number, plus an odd is odd. So in both cases, I'm not trying to write it down anymore. I want to do some subside inclusion. I feel like using subside inclusion. Okay, awesome. We got a x5 plus x4 plus x3 plus x2 plus 1. Okay. If x is odd, even, odd, can't get 0. It's an even number. Even plus even plus odd is not even, because that just simplifies to even plus odd, which is odd. And then if it's odd, well, it's the same thing. This becomes even, this becomes even, this becomes, and it's odd. So let's just go here. Let's see what they do. Yeah, so they just, oh, yeah, so they just say the same thing. They just do it more professionally than I do, which is probably the way you should be doing it. They say m and n. They say it's equal to, x equal to m over n because it's a rational number. So, which means m cubed plus m squared n plus n3 is 0. If m and n are both even, and we contradict their those terms, if yeah, so if m is even and n is odd, then m cubed is even, and n cubed times n is even, and n cubed is odd, producing an odd number, which is impossible. Yeah. So last week m is odd and n is even, m3 is odd, m squared plus n3. Yeah. So adding these odd numbers together is also odd. An impossible conclusion. Yeah. Must be the case that the equation has no rational roots. Assume x3, and then, yeah, so they just expand it again. Both m and n are even, so they contradict that they were in the lowest terms. So again, it's mostly just contradictions, contradicting the word terms if m is odd. So usually they won't give you rational ones, but we can come back to these people really want to. Leave a comment on the VOD if you want me to come back to this. If you want me to come back to those questions, I will return. Anyways, for now, we're going to go up to 32. Prove the following equations have no natural solutions. Okay, so x squared minus 4y squared is equal to 7. Okay, so this one, interesting. So is this well ordered principle, I wonder? I'm not going to assume. Okay. Okay, so I was not going to prove it like this. I'm stupid. This is an important notice, is to recognize difference of squares when you see them, especially when you're dealing with primes. When you are dealing with primality and prime numbers, recognizing difference of squares is very important, because when you recognize difference of squares, it recognizes that those numbers are a factor of that prime number. So here we can say factor it to be x minus 2y and x plus 2y is equal to 7. Thus, again, because it's prime, x minus 2y is equal to 1, or x plus 2y is equal to 7. Again, or the other way around. Let's put in big brackets. I am not going to prove it I'm not going to do both, because it's pointless for me to do both. If I do one, anyone watching should get the gist of it. Cool. Okay, so x minus 2y is equal to 1. So y is equal to, or I guess we'll do positive y, it's just better like that. So 2y is equal to 7 minus x. So y is equal to 7 over 2 minus x over 2. And again, we can find x pretty easily. Use what x equal to 7 plus 2y. So wait, I fucked up somewhere. I think I used the same equation. No, I didn't. Why am I having so much trouble with this? I see why. I'm stupid, that's why. This would be minus 2y. So then we have 2 2y, y is equal to 3 minus y. And you get 2y's, and then you get, if you refresh just y, you go from 3 over 2. 3 over 2 is not in the natural numbers, so this must be a contradiction. Again, very important. Recognize the difference of squares here. A little bit different though, because 10 is not prime, actually. So we have a little bit of a different situation. I don't know if you break this up into factors, because 10 has a lot of factors. Actually, no, it doesn't. It just has 5 and 2. My bad. Has 5 and 2 and 10 and 1. So there's 4, I guess you could do. I think you're ready to show one. We're gonna show this one. I'm sure it'll be the same both ways, but I'll check the solution for that. Negative 3 over 2. Let's see if that's what the solution got. Negative 3 over 2 is a solution nowhere? Really? Let's see. Okay, they didn't even bother with the 5 over 2 solution. Which doesn't make sense, because whatever. Oh shit, guys. Prove out the equation. Has no natural solutions. Okay, so I actually don't know how to complete the square. Real talk, I don't know how to complete the square. Guys, I don't know how to complete the square. I'll come back to this one. What is this, like, induction proof? Two squares from two opposite corners deleted as a checkerboard. As shown below, the remaining squares are going to be covered using copies of the T-shapes and their rotations. Is that right? Oh, wait. Yeah, I don't know how to complete the square. We'll do it later. Interesting. So if someone's two squares, the remaining squares will cover remain T-shape and its rotation. Since 60 squares remain, 15 shapes must be used. Each T-square is an odd. Since the sum of 15 odd numbers is always odd, any board formed by 15 T-shapes has an odd number of squares of each color. One remaining board has 30 squares of each color and can be covered by 15 T-shapes. Alternatively, since the region of the number of squares can be covered by each color, one can conclude that must be of 3 black and 1 white. Since 60 is not 4 times an even number. That was a dumb question. Oh, K is 4. So yeah, M would here, M would be a prime number. Because again, 2, 3, 5, and 7 don't divide it, because 2, 3, 5, and 7 don't divide 1 either, right? So like if a prime divides a number, A plus B, it has to divide A or B. If it doesn't divide A or B, it's not a multiple. Repeat with P1 to PK with the following primes. And again, I am not using that. Okay. We're done. Logic. What else? I'll do a couple doses and inclusion questions with you guys. And then I think I'll take a break for a little wee bit. Just cause, why not? Okay, I'm not gonna do all these, there's a lot here. Functions. What the fuck are we doing with functions? Okay. Is there any double system? Can I just show that they're equal? I don't want to do any of this extra garbage. We'll do 11. And for whatever reason, there is no double system inclusion questions here. So I think the rest of them are. Oh, there it is. Interesting. There's a bunch. Okay, we'll do 11. What can we put about A and B? So if A minus B is equal to B minus A, then okay. Prove the following set identities. 21. We're going to do this entire question together. And we'll take a little bit of a break. And we'll get back to this later. Okay. So we'll prove the first one. And again, here you're supposed to say, we're going to prove this by double set inclusion, yada, yada, yada. I'm not going to do that here. I'm just going to hop right into the proof. So we're going to show A intersection B complement is a subset of A complement union B complement. We write this saying X saying it's in the complement is equivalent to saying it's not even in the set at all, which is true. So X is not in A intersection B. Thus, X is not in A, or X is not in B. Right? Again, we can rewrite this as then. I'm just using random connecting words. X is an A complement, or X is in B complement. Thus, X is in A. Okay, cool. Other way. I don't like that box. Okay. So saying that X is not in A or X is not in B is equivalent to saying X is not in A and B. Uh, I hope this proof is correct. I'm going to send this to my intelligent friend to verify it. So if you're watching this and I did end up sending it to you, let me know if this is correct. Thank you. All right, number B. I keep writing this down wrong. A minus B union C is equal to A minus B intersection A minus C. O direction. Okay. I don't know if you can factor out like this. Like above, I said simple. I said expand the x and a. Logically, it is correct, but I don't know if you can just say it. But we'll do it anyways for now. And you probably should put some words here saying thus they show that this since they're subsets of each other, they're equal. And that would be. I'll call that simple file. Let's call like group. Oh, I guess you can expand it. Yeah, okay, let's expand it. The union though? A union. Oh, yeah. I'm lagging, guys. My thing is getting a little laggy because there's so much writing, which is a big problem in OneNote. Microsoft, if you're listening to this, please optimize OneNote. It is fucking terrible having to deal with lag after my thing gets over like 2 paragraphs long. Please fix it. Again, this was fourth order. Doesn't matter. Just does not matter. It's just the way I wrote it. If I probably was writing this on an exam or something, I would make it for correct order, but I'm not. And again, I'm literally just alternating between thus and that. I don't know what's better. I need some feedback on that. But yeah. Mm. All right, number D. All right, let's get after it. Okay. Oh shit, I missed like half the fucking set. Hmm. We can actually expand both terms. So we can say it's 1 or wait. Hmm. What is B intersection C? So X is in A and X is in B. And X is not in B. Oh. Hmm. Yeah, so that's true. X is not in B intersection C means X is not in B or X is not in C. So why? But if you expand it, you get something that's wrong. Let's try it anyways. This just cancels out. This whole statement here is never going to be true. Contradiction. So we get X is an A. So this whole thing is just false. It's always going to be false. Oh, guys, I understand now. So the statement just becomes X in A and X in B and X not in C. And I guess here you just factor like just what X A. Okay. The only question I have here is then technically you should be able to group the X in A and X is not in C together. Yeah, see like a scratch and one with trash. But then like this gives us the right answer. So I think something like there's a folly here. so sorry, guys. OneNote is trash. Whatever, this is the last thing I'm doing on this page anyways. So, let's kind of skipped a step there. But it's fine. This would be or. No, this would be and. Yep, that would be and. So what am I trying to do? A intersection B and B intersection C. Okay, I guess let's expand. Expand the A in. It's not really what we're looking for though, eh? Is it? So what if we just add that BS term? Because again, this changes. Nothing adding this. So logically equivalent. Shouldn't be against the rules. So again, same thing. Alright guys, that is the last proof. I'm going to stop for now, take a little break. Probably won't stream again today, but maybe I'll stream maybe tomorrow. of the day. That is test day, so I hope everyone here wishes me luck. But I may stream tomorrow if I have some time. Thank you for joining me today. Have a great day.